Disgusting A-level maths questions. We're back, but we're going to have a slight change of pace today. So I don't want to give you a question that's just disgusting in the sense of 25, 30 lines of algebra and crazy equations and stuff like that. I'm actually going to do a much shorter one today, and it's going to be hard in the sense of when you initially read the question, it might not be immediately obvious what you need to do, as opposed to just, something mad where you've just got to grind it out. So I'm actually going to use a stats question today, and it's going to be from year 12. It's going to be on the binomial expansion. So let's give it a read. It says X is binomially distributed with 8 trials and a probability of a successful trial 0.539. Given that 3 values of X are observed, find the probability that less than or equal to one of these values is exactly equal to 4. Okay. It's kind of confusing here because, the first sentence says we've got this binomial distribution, but then it gets a bit confusing later on because it's talking about 3 values of X, but then less than or equal to 1, and then the 4, and then the 8 trials. So let's try and kind of unpack this. Sentence 1 is the only one I want to start focusing on, and it's essentially just saying what? That X is binomially distributed with 8 trials and a probability of success being 0.539. So that we know. We've cashed in the first sentence. So what is this? It's a binomial distribution. It's got 8 trials. So essentially 8 trials, 1, 2, 3, 4, 5, 6, 7, 8. You're going to get some of these being successes and some of them being failures. And you're going to come out with some amount of successes. I don't know, you could say 4 successes. Or you could get 5 or 0 or 8. Something like that. So then what happens? It says, given that 3 values of X are observed. So this is where I want to stop. Given that 3 values of X are observed. So this right here, X, as we know, if I run the X experiment, I do 8 trials. But then it says 3 values of X are observed. So what's actually going on is we're going to have a binomial inside another binomial here, and this is the trick that you really need to get, because what's going to happen is I do my X with my 8 trials. Then I do X again with another 8 trials, and then I do it again with another 8 trials, and then these 3 things are going to form, each of them are going to form a single trial of a new binomial. So that is the key here. I have a binomial within another binomial, so I could call this binomial Y, for example. So if you think about it, Y has got 3 trials, and each one of those trials individually has 8 trials. So that's what's going on here, and that's quite tough to understand. So what this is saying is the following. Given that 3 values of X are observed, the 3 values corresponding to the trials of Y, find the probability that less than or equal to one of these values is exactly equal to 4. So what would my probability of success be? What am I trying to count here? Well, a success on a single one of these trials is X being equal to 4. So in this case, that would be a success because when I ran the X, I got 4 successes. But then, for example, if I ran this one and I got 5, that would be a failure, wouldn't it? And then if I ran this one and I got 0, that would also be a failure. So what it's saying is, what is the probability that I get less than or equal to one of these 4s in the Y trials? So there's a lot going on, isn't there? What we always need to do with these distributions is write out the distribution. So how is Y distributed? Well, we know it's binomial. We know there's going to be 3 trials, each of these trials being a whole experiment for X. And what is the probability of success on a single trial going to be? The probability of success on a single trial, P, is going to be the probability that when I run the X experiment, all 8 trials, I get 4. In other words, this P here is going to be the probability that X equals 4. So it's almost like I'm counting the whole ones for the X trial, and then that's just going to make a single trial for the Y. So this probability I do know how to get. If I go into my calculator, 7 for distributions, I want binomial PD here because this isn't exactly equals to. So this is probability distribution. If it was less than or equal to, I would use binomial CD because that means cumulative distribution. But in this case, I'm going to press PD I'm going to go to variable, and I'm going to input the parameters of my distribution. N is going to equal 8. P is going to equal 0.539, the probability of a single success. And then X is going to be this number here that I'm trying to find out, which is going to be 4. So putting that in, I get 0.26684. 5 decimal places is enough right now. I definitely want to go quite a few because I'm going to be using this answer later on. So this is now going to be the P for a single trial for my Y. Now we can reread the question with the new information of Y. So find the probability that less than or equal to one of these values is exactly equal to 4 is now just saying the probability that Y is less than or equal to 1. So now, still got my calculator up, so I'm going to stay in the binomial... no, I'm not. I'm not going to stay in the binomial PD now, am I? What did I just say? When it's a less than or equal to, we switch to the binomial CD. So I'm going to go back out, into the menu, distribution, and then I'm going to go down into the binomial CD, cumulative, accumulating the values up to 1 here. But again, variable. X is going to be 1 because that's what I'm interested in. N is going to be the amount of trials in the Y distribution, which is 3. And P is going to be my answer from last time, which is the 0.26684. Putting all of that in, I get my final answer to 3 decimal places to be 0.824. So a much quicker one today, but it's cheeky. It's got a bit of spice, hasn't it? Which, if you read that and you don't know what you're doing, it's very hard to even make a start on it. Cool. So I got this question from my AITutor. And if you want to have a go at this question and many more like it, head on over, and you're also going to get the full worked solution to it as well. See you in the next episode.